Hi kids, now we'll be going with this small question like what will happen to the water level if the ice melts. So basically, so these are the questions I will be discussing the other way. So you can just pause and read the question. So this is the next one. Anyway, I'll be dealing the other versions of the same question. So basically let us go with the very common question. That's like when ice is kept on water, it will be floating because density of ice is only 0.9 times of density of water. So 0.9 volume will be submerged inside and remaining will be floating outside. So it is in equilibrium, so weight will be balanced by buoyancy. Weight of the ice is density of ice into volume of ice into g. Now that equals to buoyancy. Buoyancy is density of the liquid, that is density of water into volume submerged into g. So that is by making net force equals to 0. Now if this ice melts, it will give us water. So mass will remain same. Mass of ice melted equals to mass of water formed. That is density of ice into volume of ice equals to density of water into volume of water formed. So when you take the ratio, you will get volume of water formed is exactly volume submerged. The other way of saying it is, if you take so volume of water formed is only this much amount, which is volume submerged. The other way of saying it is, if you take the ice out, you will be having a cavity here. If you melt it into water and if you pour it, it is going to fill exactly to this amount. So basically height of the water level is not going to change. Now we can see the same thing in a slightly different way. If I draw the free body diagram of water and ice together, then there will be weight of ice and weight of water, which will be balanced by the force from the base, which will be pressure there into area. Now even if this ice melts, we have seen it is going to fill exactly this much amount of volume. Anyway, we don't bother about that. So let me say I have melted this, but still mass is going to remain same. So weight of ice will be weight of water, new water formed now. Apart from that, there is weight of the existing water. Now these two weights are not changing. Even after it melts, it is not going to change. So weight of these two things is balanced by this pressure force. So weight of these two things must be balanced by this pressure force. So I can conclude this pressure force and this pressure force must be same. So if this pressure and this pressure are same, you can easily conclude this height and this height will be same. So height is not going to change. Now if there is a cork ball inside the ice such that it is floating. Now if the ice melts, cork will be still floating. Now I need to convince you the water level is going to remain same. So I will be drawing the free body diagram of ice plus water plus cork initially. So there will be weight of water, there will be weight of ice and weight of cork, which will be balanced by the pressure force here. Now even if it melts, ice will melt and water will be formed, so still that weight will be same, and weight of the cork, and apart from that weight of the existing water. All these weights are remaining same. So all these weights are balanced by this pressure force. So all these weights will be balanced by this pressure force. So this pressure force and this pressure force must be same. So this height and this height will be same. So water level is not going to change in this case. Now in this case, if there is an iron ball inside ice cube and it is floating, so if ice melts, then this iron is going to sink. Now I need to convince you the water level is going to reduce. The other way of doing it or explaining it is, draw the free body diagram. Weight of the ice plus weight of the iron plus weight of the existing water will be balanced by the pressure force from the base of the beaker. Now once it melts, it is going to hit the bottom. Now weight of the water formed will be same as weight of the ice already, and weight of the water existing, weight of the water existing, and weight of the iron ball, weight of the iron ball. Now all those weights are remaining same, but it is coming in contact with the beaker, so there will be extra force coming, contact force normal, right? So all these three weights here are balanced by this pressure force. All these three weights here are balanced by this pressure force plus this normal. So from there I can conclude this pressure force will be less than this pressure force. So basically this height will be less than this height. Now if there is a balloon and ice cube is floating like this, if I cut the balloon, I need to convince you water level is going to increase. So the other way of saying it is, I have drawn the free body diagram. See, basically concentrate on water plus ice. On water plus ice, there will be weight of ice and weight of water and tension from the upside. Tension from the upside. So don't bother about this, just bother about this. Right, so M1G plus M2G is balanced by tension force plus this pressure force. Now once you cut that, M1G plus M2G is balanced by only this pressure force. So M1G plus M2G is earlier balanced by tension plus this pressure force, but it is balanced by this pressure force alone now. So basically this pressure force has to be more than this pressure force. So the other way of saying it is, this height is more than this height, right? So this pressure force is more than this pressure force. So here water level will increase. Now I can easily convince you even the volume submerged is going to be more here, because here buoyancy needed is less, there is tension already, right? So here buoyancy needed is more, so volume submerged will be more here, right? So now these three questions must be making sense to you. So when something is floating, water level is remaining same. When something sinks, water level will decrease. In this particular case, water level will rise a bit, right? Thank you.